Yeah, thank you all. Welcome to the Aga International PLC business. So please, if you want to get us for this link, we're about to impart to people on indices. So what we have today is algebra part 1. Then, indices, we are talking about the base and power. From this point, we have the linear, involving linear quadratic equation. The first one we have 3 raised power equals to 9. So this is the question. So let me impart to people more how we got these answers. Then from this point now, because this one is indices involving linear equation. The first one is that we are considering power and base. Power and base. So when I talk about this point now, so how we got this 3 raised power 2 simple means that you have to make this the same base from this right hand side and the left hand side. You have to make it to be equal. Then from this point, how we reduce this point here is because of this 9. Then ask yourself, how many 3's inside 9? How many 3's inside 9 we have that? How many 3's inside 9 is 2. That's how we got this 2. So meanwhile, from this function, any place we see 9, then we substitute with 3 raised to power 2. Therefore, you can see that this is 3, this is 3. The base now, you have to eliminate it by bringing down the power. The power here is s, and also the power here is 2. Therefore, the answer is s equal to 2. So that is how to do it. So the reason why I go straight to the number 3 instead of number 2, because number 1 and 2, they are equivalent. You will follow the same method. So this number 2 now, you can try it at home by subscribing agamsinternational.com. Then number 3 have 3 raised to power 2s minus 3 equal to 81. So from this point now, to reduce it to the lowest number so that the right hand side of this base and left hand side of this base will be the same. Then from here, you ask how many 3 is inside 81. We say that how many 3 is inside 81 is 4. Because if you say 3 times 3 times 3 up to 4 times, you get 81. So in placement of this 81, then you remove 81 and substitute 3 raised to power 4 so that you get the same base and base. So when this base and base cancel each other now, you bring down the power. So how we go 2s minus 3? This is 2s minus 3. And also, this is 4. This 4 is this. Then, next one, you collect like terms. How we collect like terms is because this one contains 2s, while this one does not contain any alphabet. So what I'm trying to do, you collect like terms. This minus 3 now will cross equal sign. Anytime minus cross equal sign is plus. That is rules of mathematics. So therefore, you have it as 4. Because of minus, this is plus. That is 4 plus 3 is what? 7. For we to make s the subject of the formula, by dividing the coefficient of 2s, divide both sides by 2. Divide 2s over 2, then 7 over 2. You get it as s equals to 7 over 2. Or you can put it in whole number. You ask yourself how many 3, how many 2 is inside this. You have it as what? 3 whole number 1 over 2. 3 whole number 1 over 2. Therefore, if you want to know whether I correct or not, you can simply say 3 times 3 is 6 plus 1 is 7. That 3 whole number, you have it as what? 7 over 2. So that's how to do it. That is indices involving linear equation. Indices involving linear equation. So from this point now, we are going to look at this point. This point, you have it in decimal point. Decimal function. So from this decimal point now, we are facing the laws of negative index. So what I mean by negative index is by converting the reciprocal. So what I mean by negative index, when I have 4 raised to power, when I have this point 4 raised to power this, that is 4 raised to power s equal to 0.5. So you can see now this point now they are not the same. So for we to get the value of s, you can simply say that we repeat 4 raised to power s equal to, this is decimal point. So we have to make it to be fraction, that proper fraction. So we can simply say that this one you call it 5. Then after decimal point, this point you call it 1. The next digit, which is 5, you convert it to be 0, which is 10. You have it as 5 over 10. Then from have it as 5 over 10. If you want to know whether you are correct or not, you can still make use of your electronics, which is calculator. By pressing 5 divided by 10, you will say arrive at 0.5. So we are still heading somewhere. Then you can simply say that 5 divide himself, you have 1. 5 go into 10, you have 2. Then you have it as 4 raised to power s equals to 1 over 2. Still now, the base, they are not the same thing. Then you go by using the rules of what? Indices. Simple say that reduce this 4 to be lowest number. Then ask yourself how many 2 is inside 4 is 2. Then we have it as 2 raised power 2 s. S is this. 2 raised power 2 simple mean what? 4. By saying 2 times 2 is what? 4. Then you have it 1 over 2. Then you remember the rules. Now if you go to indices, you go to rule number 5. When you have this, it is the reciprocal of 1 over a. So do you believe that when you have then 2, it is same thing with this 1 over 2? Can we do that? Yes. So meanwhile, any place you see 1 over 2, then we remove 1 over 2 and substitute 2 minus 1. So let's go there. Now you have it as 2s into, from this point you have 2 minus 1. So you can see now the base are the same now. So we can cancel this go, then you bring down the 2s into minus 1. So from this point now you can divide both sides by 2. Then by making s the subject of the formula, you have it as 2 divided by 2, 2 divided by 2. When this one divided by this, you have it as s equal to minus 1 over 2. So that is how to do it. Any number that involving decimal points, know that you get the reciprocal of each questions. Are we okay? So let's go to the second examples. This is example 1. Thank you. So in second examples now, we are talking about the second example. We are talking about indices. The same linear indices for second examples. If I ask now from this point, when I have something like this, 2, 3, 2s plus 1 equal to 27. That is another example now. Then from this point I have 2s plus 1 into, in this point now you say how many 3 is inside 27? I say it's 3. So any place I see this 27, I will have it as 3 raised power 3. It is something by saying 3 times 3, which is 27. So we substitute 3 raised power what? 3 from this point. Then I can say that this one cancel, this one cancel. Are we okay? Then you bring down the power. Then from this point, have 2s plus 1 equal to, you have it as what? 3. Then from this point, let us make, we are trying to make x the subject of the formula. Then have it as 2s plus 1. Well, from this point, you have it as 2s equal to 3. Remember, it's positive. Positive cross equal sign is negative. Are we okay? Then have minus 1. Then from this point, you have 3 minus 1 is 2. Then from this point, you have 2s. So remember, make s the subject of formula. Divide both sides by 2. Divide both sides by 2. When you divide it now, you have it as, this divided by this is what? 1. So that is s is equals to what? 1. So that's how to do it. Remember to bind with Adams International PAC. It's good to go. The next one now, we are talking about indices involving quadratic equation. Indices involving quadratic equation. Then, in indices involving quadratic equation, remember we have equation we are talking about when you have anything raised to power 2, then you can use 3 method. Like when you're having something like this, here I'll remove what? Linear. Now we are doing quadratic what? Equation. Indices involving quadratic equation. So from this point now, we are talking about quadratic equation. Remember quadratic, we are talking about factorization method. We are talking about complete square method. We are talking about graphical method, etc. So let's watch the example. Remember, we see under indices. Then from this point now, when you have 2 raised power this or into this minus 5 into 2 raised power 2s, that is plus 4 into this. So this one now is good to go. Though we're making this thing, Adams is making things easier for you. It's easier for your exam. Once you follow our website, you are good to go. Then from this point now, I will write from what? Solution. You write solution first from this point. So when you have a solution now, from this point now, we have to balance it to be in quadratic form. So how can you do that now? You can say, I can say that 2 raised power s. I can say, let 2 raised power s represent any alphabet. Okay, I will say that let 2 raised power a represent Adams. And remember, I will say, let 2 raised power a represent what? A represent Adams. So I will say A. Remember, any place you see a, no, we're talking about Adams. So from this point now, any place I see 2 raised to power s, I will put it here. So from this point, I have it as a into raised to power 2. That is first one into this bracket a, that is next one, plus 4 into what? 0. Remember, I'm trying to form my quadratic equation. Then I'll have it as 2 times a is a square. So I have it as a square minus 5a plus 4 equal to 0. So I've formed my what? Quadratic equation. So in this case, I can use any alphabet of my choice. Okay, let us use what? Factorization method. To know the value of what? A Agams. A Agams. Take note. A Agams. Then from this point, I say using factorization method. Using factorization method from this point. So when I use factorization method, in factorization method, what I have to do is that I will take 2 numbers. 2 numbers that when I multiply the number now, I'll get the constant of 4. I use the same number, either I add or subtract, I'll get the coefficient of 5. Then we ask Agams. Agams, what is the numbers? Agams will tell you the numbers now. So watch now. Then from this point now, from here, then from this point now, from this point, you are taking the question. So I can say that the number will go this way. If I say minus 1 minus 4, it will give me what? Minus 5. So we are getting minus 5. Then if I use the same number now, I say minus 1 times minus 4, it will give me plus 4. So have you seen that diagram? I've already give you the answers. So I can substitute alphabet here because we are dealing with alphabet. And remember our alphabet, I say minus 1. I'll put it minus Agams, which is what? A. So minus 1. Then from this point, I'll put what? 4a. If I say minus 5 minus 1 minus 4a, it will give me minus 5a. So meanwhile, from this function, now from this expression, any place I see minus 5a, I'll now remove the whole of this minus 5a and substitute with this. So let's try this now. Then from this point now, we have it as here, we have a square, then minus 5a, sorry, minus, in placement of minus 5a, put minus what? A minus 4a, then bring down the constant is what? 4 equals to what? 0. Then from this place now, I can say that I want to factorize out. I can simply say that this into this, then this into this. Are we okay now? I just separated the bracket. Then let me factorize now. The highest alphabet of Agams here is A. So I'll bring A. So remember, A represents our Agams. So from this point, I say A. If I say A times A is A square, it's the same thing. Then I simply say A divided by A is 1. So I have it as what? 1. Because if I say A times A square, A times minus 1 minus A is correct. Thus the equation is balanced. Then next one now, minus. Then I'll bring down 4 here because 4 is here, 4 is here. Are we there? So I have 4 into A. So from this minus now, this minus here, I will say minus times plus is minus. Minus times plus is minus. Then this 4 divided by 4 is 1. So I have it as 1. You close the bracket equal to 0. Then are you see something? Yes, you can see that bracket and this bracket, they are all the same. They are common. What you have to do, you bring the word, you take 1. Then the one that is outside the bracket now, you bracket it together. Then from here, you have this A4 into this. So since this and this, they are the same, I'll pick 1. A minus A equals to 0. Remember the function of 0 here. 0 trying to tell you that now, this point now have 2 equations. Equation can be negative, negative, or positive, positive. That is the rules of what? Agams. Then from this point now, you have it as A minus 4 equals to 0. Then, or A minus 1 equals to what? 0. Then from this point, I say A into 0 plus 4. Because this one equals equal sign. Or A equals to 0 plus 1. Are we okay? Then I'll say A equal to 4. Because 0 plus 4 is 4. Then, or A equal to 0 plus 1 is what? 1. So remember now, this is not the answer. This is not the answer. Remember the question said that we should find the value of x. Then you go back. You say, let us bring the agams up by saying from this point now, I will say that note from the first one, you say that note that place you have 5 raised to power s equals to what? A. Are we okay? Therefore, okay, 2 raised to power s. 2 raised to power s equal to what? A. Then therefore now, I will say that when 2 raised to power, when A is equal to, the first A is equals to what? 4. Therefore, your agams of s now will be from this point 2 raised to power s is equals to 4. So this A I put 4. So remember we are solving indices now. Then we have it as 2 raised to power s. You ask yourself how many 2 is inside 4 is 2. Then you have 2 raised to power what? 2. Then I will take this one out. Bring down the power. So my s is equals to what? 2. So that is how to do it. The next one, then from this point, I think part 1 is the common. This is part 1. Contention of part 1 is about to conclude. I still remember my humble self, Charles, the mass man, partner with Agams International. Thank you and God bless you.